Welcome children. Now we are going to discuss about another topic from the unit light, which is about multiple image formation. In our previous class we discussed about two laws of reflection. Can you remember them? Among that first one, which was it? That is incident ray, then reflector ray, third one normal, incident ray, reflector ray, and normal drawn at the point of incidence are lying on the same plane. Then another one was angle of incidence equal to angle of reflection. That is angle I is equal to angle R. These were the two laws of reflection we studied in our previous class. Then regular and diffused reflection. What is actually regular reflection? Can you remember it? There is in a plane and a smooth surface when parallel beam of light, parallel beams of light rays incident after reflection, they also becomes parallel. That means if the reflector ray is also parallel, then we can say that one is a regular reflection. Then what about diffused reflection? When light incident on a plane surface, that is not a smooth surface, even though the surface is plane, the surface is not smooth, that means a rough surface, then the incident ray and reflector ray, when we consider, the reflector rays are not parallel, and that type of reflection is called diffused reflection. Diffused reflection. Now we want to discuss about can reflector rays again reflected. Is the reflector rays can reflected again? For that, we know a plane mirror can form only one image. When we consider a plane mirror, it forms only one image. But when we use two plane mirrors at an angle, see, two plane mirrors placed in this manner, that means it edges join. This one plane mirror, this another plane mirror, they join at right angles as shown in this figure. It is an activity for you to find by arranging in this way two plane mirrors, how many images can it form. For that, you keep a lighted candle in between them. Then observe how many images is formed on this. You can see there are three can see 3 images on the mirror of this lighted candle. Now, by changing this angle to some other angles such as 45, 60, 45 degree, 60 degree, 120 degree, 180 degree. That means you change this angle, that means this mirror you form in this way. Now the angle changes to 45 degree. Then observe how many images is formed here. Then change. Now the angle between these two plane mirror is 45. Observe how many images can you get. Note it. Then forms angle between these two to 60. Now the angle is 60 and observe how many images can see in this mirror. And then make this angle 120 in this way. Now the angle between two plane mirror is 120 degree. Again you observe how many images on this mirror can see when we place this lighted candle in between them. Then make this 2 at 180 degree. See, now the angle is 180 degree. Now again you observe how many images can you see in this mirror of the object, this lighted candle. Notice it, how the angle changes and the number of images changes. That means this can be calculated. That means the number of images n. You got, that means when the angle is 90, you got 3 images on the mirror. When you change angle 45, you can find that this total angle 360 by 45 minus 1. This gives number of images. 360 by 45 minus 1. 360 by 45 means 8 minus 1. That means you can get 7 images. Or you can see 7 images in between this mirror. That is, this mirror you can see 7 images of this candle that you can observe. When the angle is 60, that means number of images you can see is equal to 360 by 60 minus 1. 360 by 60 is 5 minus 1. Then 360 by 60 is 6. This minus 1 you get as 5. Number of images you can get 5. When the angle is 90, 360 by 90 is 4. 4 minus 1, 3. When the angle is 180 and 120, that means 360 by 120 minus 1. This will get 3 minus 1. That is, you can get 2 images. When the angle becomes 180, what happened? 360 by 180 minus 1, that is 2 minus 1, you get only 1 image. You get only 1 image of that candle. So, these are the things you observe. That means the number of images varies with the angle. Number of images varies with the angle. So here you see, when the angle between the two mirror is 90, we got 3 images of this angle on the mirror. When it becomes 45, how many images we got? 360 by 45. That means 7 images is getting here. When 60 is 5 images and here 1. This way we are getting images. Now see, by arranging mirror in this manner, we can get a number of images, and by using this device we are making. This is the periscope. Here you see 2 mirrors. See, this one mirror, and here is another mirror. That means by you seeing this, you can see other side. That means this periscope here on mirror in this manner, here another mirror in this way. 2 mirrors arranged. That means at an angle, then we can see. That means object. That means here the object, by looking through this side, we can see the images of this mirror. And this mainly used in submarines. This periscope is used in submarines and soldiers in bunkers, and also soldiers in tanks to see the object outside. They cannot see the object directly, but they use this device. Now see, if these 2 mirrors are arranged in this way, this one mirror, this another mirror, and if the candle is placed in between these 2 mirrors, how many images can you see? You can see a large number of images, a very large number of images on in this manner. We can see very large number of images of this lighted candle in these 2 mirrors. Not only 1 or 2, a large number of images we can see in this device. Now this idea is used to make that means in the case of kaleidoscope, that means to making kaleidoscope, by arranging mirrors at an angle, we can get a large number of images, and that method is, or that idea is used to make different patterns in kaleidoscope. To make a kaleidoscope, we require 3 plane mirrors. Three plane mirrors arranged as like this. That means 3 sides of a prism. In this manner, we want to arrange 3 plane mirrors. And then it's on edge. And after that, that means arrange 3 plane mirrors in this shape, just like a prism. Then one end of it is covered with a cardboard and make a hole, and another end with a plain glass plate, close it with a plain glass plate, just like this one. See, 3 plain mirrors arranged in this manner. It's one side like this, and other side in this manner arranging, and then it is covered with some thick paper, and one end of it is covered with a cardboard with one hole. Then the other end, a plain glass plate. Then inside it you make some different colors. That means pieces of small pieces of mirrors or pieces of bangles. Then that means just like this one. That means here you can see what you can see here. Here the part of what is a large number of pieces of what is bangles. Here is an opening, and inside there is 3 plain mirrors arranged in this manner. When we look through this, we can see different patterns. That means not only 1 or 2 patterns. When we look one time, you can see here only one type of pattern. And when you change after again, you see another one pattern. That means the pattern changes at a very time. That means the pattern obtained in the kaleidoscope changes at every time. So it is used by the designers to get different patterns. And also the painters or such type of architect, they use this device to get different patterns. That means from the kaleidoscope we get different patterns. So now you know how to make a kaleidoscope. For that you require 3 plain mirrors, and how that 3 plain mirrors arranged in this manner, and that plain mirror keep in a pipe, and one end of it is closed with a cardboard and make one hole there. Then other end with closed with a plain glass plate, and it a number of small pieces of mirror or what is pieces of bangles. Then you can get different patterns from this, and that is used by what is designers to get different patterns. Now we want to know sunlight, is it white or colored? Sunlight is white or colored? That we want to know. For that, we can do one activity. Take a cup and place a plain mirror in it. This is a cup. And place a plain mirror in this manner. And fill it with water. After placing, allow sunlight to fall into this plain mirror. That means this is the sunlight falling in this plain mirror, which is placed in water. Now this arrangement acts like a prism. Now this arrangement is just like this prism. See, when sunlight falls on this plain is reflected, and the reflected light is allowed to fall on a white wall. If the wall is not white, then you paste a white paper there. Now the light reflected from this, that is a light that is falling on this will get reflected, and this reflected light that falls on the wall or white paper, you see here there is a slight path deviation. You get different colors. You get different colors on the white wall or the paper. You get different colors in this white wall or the paper which we pasted on the wall. Now this sunlight split into different colors. Sunlight is split into different colors, and this phenomenon is called dispersion. Dispersion of light. Now sunlight is split into different colors. You cannot get white light on the screen, but what we get different colors, and this splitting of white light is called dispersion. What it is called? Dispersion of light. One of the commonest or simplest examples for dispersion of sunlight is the rainbow. Dispersion of sunlight is the rainbow. That means in the atmosphere, just after the rain, there is millions of droplets of water. Within that water droplets, sunlight disperse. Due to that dispersion, rainbow is forming. Due to that dispersion, rainbow is forming. So from this, what we get, even though sunlight appears white, but it is composed of different colors. It is composed of different colors. That idea we are getting from this activity. Now we want to know what is inside our eye. Our eye actually helps to view objects. Its outer part is, that means outer part of the eye is white color. That means outer edge of the eye is white color, but it is very rigid, so it protects from any injuries to the eye. Its front portion is a transparent part, and that transparent part is called, just like that figure, see, this is our eye, and you can see the structure, and see the front part of the eye is a transparent part, and it is called cornea. Behind the cornea there is a dark muscular part, and it is called iris. But it is called iris. In the iris, there is a small opening. There is a small opening, and it is called pupil. And it is called what is a pupil. That means we want to know actually what is inside our eye. Outer part of the eye is white color, but its nature is very rigid or very strong. So it protects the eye from getting any kind of injuries. At the front part of this eye is a transparent part, and it is called the cornea. And behind the cornea there is a dark muscular region or muscular part, and it is called iris. This iris contains a small opening, and it is called pupil. Through this pupil, light entering into the eye. And it is controlled by, that means the amount of light is controlled by the action of what is this iris. Actually, color of the iris is the color of the eye. Suppose a person with a blue eye, it means his iris is in blue color. His iris in blue color. And light entering through light entering through this pupil falls in the eyelids. And this eyelids allows, that means eyelids is a convex lens, and that focus image of the object in the retina. In the retina there contains a large number of sensory cells, and from there that senses goes to brain through optic nerve. The junction between this retina and optic nerve, at the junction of retina and optic nerve, there is no sensory cells, so that region is called a black spot. At the junction of what is retina and optic nerve, there is no sensory cells, so the vision is not possible at that part, and it is called what? Black spot. Sorry, blind spot. What is called? Blind spot. In the eye, there are two kinds of sensory cells. Cone cells, which have to see colors, and also it works in bright light. Cone cells, which works in bright light, and another one is a rod cell that function in dim light. Which a rod cell. What is a dim light? What is a blind spot? Then rod cells works in dim light and cone cells in bright light. The part which help to distinguish color, actually what is a cone cells that help us to see colors, but rod cell which works in dim light. Now these are the main parts of the eyes. Once again, see, this is the structure of the eye. That is, this part is cornea, the front transparent region. And there is what is iris. Behind this, there is iris, and that gives the color of the eye. Cornea, then at the middle of the iris, there is an opening in it is called pupil. And behind there is lens. Then here you see, this part here comes retina. That is retina is here. Then a large number of portions coming here, but we want to know about these three parts only. Once again, about our structure of the eye. Which are there? Inside our eye, what are the things that we want to know? First of all, we want to know what is the shape. Outside the eye, it is nearly spherical in shape. Outside it is white in color, and the front transparent region is called cornea. Behind the cornea there is a muscular part, a part which is made with the muscles, and it is dark in color, and it is called iris. In the iris there is a small opening called pupil, through which light going to the lens, and the light is controlled by the work or function of iris. Then the lens forms image of the object that we see on its retina, that is the retina of the eye. From the retina there is optic nerve. This optic nerve transfer message from retina to brain, and the brain help us to distinguish the object. Then another things you want to remember, what is blind spot. Blind spot means at the junction of what is retina and optic nerve. At the junction of retina and optic nerve, there is no sensory cells. So at that part vision is not possible. So that part is called blind spot. Then what are the two different types of cells present which help us to see object? One is cone cells that activated in bright light. Another one is rod cells that is rod cells that work in dim light, and which cells help us to distinguish or to see color, means that is what it is. It is the cone cells. These are the things you want to know about the structure of our eye. You can see here also that is given. See, lens, that means lens, cornea, iris, then ciliary muscles, and optic nerve and retina. These are the things you can see here. Okay, now we discuss about structure of the eye. What are the things we discussed today? First of all, we discuss about multiple image formation. A plane mirror can form only one image, but by using more than one plane mirror, we get a number of images. Examples: when the angle between two plane mirror there is 90 degree, we got 3 images. When it is 45, we got 7 images. When it is 60, we got 5. Then 90, how much it is? 3, 122 and 180 only 1 image. But if the two lenses placed in parallel, then we get a large number of images that we used to make in kaleidoscope to get different patterns or to see different patterns. Then we discuss about dispersion. What is dispersion? Means lighting, that means white light splits into different colors. Example for that happening in our nature is a rainbow, that is occurring raindrop. Then we discuss about structure of the eye, that means interior part of the eye. Our interior part of the eye contains these parts. Actually, the transparent front part cornea, then it comes iris. The small opening in it is called pupil. Then what is image formed where in the retina, and there is large number of sensory cells, and from the sensory cells images goes to brain through optic nerve. Then on mutant there is blind spot. Then also about cone cells and rod cells. With this all, we can wind up today's class. Okay, thank you.